Welcome to Venn diagrams and operations on sets. This is part of an applied Bayesian statistics course at Virginia Commonwealth University. All right, so far we've talked about the sample space denoted with an S, an event E, and its complement. We did this in the last video. Now we need a few more concepts in order to understand probability. Okay, so here we're going to look at a visualization approach to this. We're going to talk about the same ideas and a few more, but first let's think about this thing that's called a Venn diagram. Basically, the square here, or rectangle, whatever you want to call it, is the sample space, and the event is a region inside of this sample space. So the circle represents the event and the box represents the sample space, and you can think about all the outcomes that belong to E will be inside of this circle. Now, we can also take this idea and extend it to the complement, right? If this box is the set of all possible outcomes, then E complement is all the outcomes outside of E. All right, now suppose we have two different sets or events, E and F, and notice they don't overlap. So here we'd have E, here we have F, and they're just two sets or events that are inside of S. Now, if they do overlap, then we can talk about where they actually overlap, okay? And that is what's called the intersection. So this is the region that they have in common, or where they overlap. So it's what they have in common between the two of them. Okay, and then we could take, well, what if we combined E and F? So we could put the two together. So this would be like adding them together versus looking at their intersection. And when I say adding them together, it's just combining them. So we're just dumping everything that's in E and F in there, and that's what we're going to end up with. And this is what's called the union, and we're going to write this with an E, with a U, and an F. Okay, so here's our picture again. We have E and F that don't overlap. What if we take the intersection? What do they have in common? Well, you look at that and you'd say, they have nothing in common, which is true. Since they don't overlap, they don't have any outcomes in common. So we'd write E intersect F is equal to this symbol here, which is the empty set. Okay, so if you see this symbol here, it's the empty set, which is the set that has nothing in it. And we need this because of this situation right here. If I have two sets or events that don't overlap, well, what do I write down? It's just like if I don't have any sheep. What do I write down? I write a 0 down. Here's the same idea. I don't have it, so I'm going to write this symbol. All right. Two sets or events that don't have any outcomes in common are said to be disjoint or mutually exclusive. You'll see people use the words interchangeably. All right, so here's a list of where we're at so far. So we have a sample space, we have an event, we have the complement, we have the intersection. It has this little upside down U here for the intersection. We have the union, which has a U in the middle, and notice the symbols are one is upside down U and one is a U, and we have the idea of an empty set. Now, what we have here is actually enough to be able to define what probability actually is. And we can also use this to come up with some other rules of probability that we're going to need as well in order to be able to function well in a Bayesian framework. But we need to move on to our next video, so see you there.